Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah, Rabbi shrah li sadri wa yassir li amri wa ahlul uqdatam min lisani yafqahu qawli. Assalamu alaikum wa rahmatullahi wa barakatuhu. Today we'll talk about searches. We have many kinds of searches, for example, linear search, binary search, ternary search, interpolation search, and exponential search. But today we'll talk about linear search. Linear search is one of the most simple and basic search. In this linear search, you scan one item until the value is found. Or if it didn't find, it will reach the end and then the value is not found. In this type of search, it is not important the data should be sorted or not sorted. It doesn't make any difference because we will be searching sequentially. Now, let me show you this search on the screen. Now, if you see, we are searching for a value 33. So it will go to the first element, then second element, third and fourth and fifth until it found the elements. If it found the elements, it will return the value or it will return the index of that location. So that is why sorting is not important because it has to go through these iteration. Now, if I go for the next slide, and you will see here we have a program. In this program, we are searching for an item using iterative method. Iterative method means we are using a loop, and through the loop we are searching for element one by one. Now, in this program, this is my array. It has like 10 elements, okay? And I will pass the value through the arguments and the value will go to the x, and the length of my array is like 10. So for example, if I pass the value, maybe for example 3, and which is not available, so I will get the message not found. So I call the search method, and then this search method will take the array. This is my array as a variable, as a parameter. Then I'm passing the left value. The left value is 0. So I want to start from 0 location. Okay. And this is the item that I'm searching for, that is 3. And the length of the item is 10. That is, I'm passing to this. Okay. Now, here we come up. So this is my array. This is my left, that is 0 value. I missed the comma. I can put the comma here. And then this is my value 3 and the length is 10. Now if you see here, since left is already initialized, so I don't need to initialize here. Otherwise I have to say left is equal to 0 or something like that. Left is like 0. So 0 is less than 10. Answer is true. So I'll come here and I'll say, okay, what is the value of v of 0? Okay, this is 10. Is 10 is equal to 3? So answer is no. So it will go back again for the next value. Now the left is 1. So it will say, hey, is the v of 1, which is 14, is equal to 3? Answer is no. So it will keep on moving, keep on looping, and until it will reach the end, and will say, no, I did not find the value. So when it comes here, it will return the value -1, and the -1 will go to this index variable. And now here I'm checking the index. Is index not equal to -1? If it is true, if it is not equal to -1, it will go here. But if it is equal to -1, then it will jump to this place and it will display not found. So this is my loop. Now let's see this on practice. Now what I can do is I can copy this part of the portion. So this is my program, this is my array, static void main. I'll take the argument value and I'll pass it to x, which I'm searching for. Then I have the length of the array and I'm calling this method now. Now let me write this method. So this is my static integer because it is going to return integer, and this is my linear search as capital, and now I'm going to get the value. So integer, I can say A or I can say V, no problem, doesn't matter, because it will be a copy of the array. And then I'm saying integer left, integer x, and integer length of the array. So I'm passing all these variables, parameters, which I need for my program. And now in this program, I'll say for, I know left is equal to 0, so I don't have to say left is equal to 0, but I have to use this, this semicolon, so that this is my initialization part. Is already initialized, so I don't need the initialization part. So I'll say less than length if, and then I say left plus plus. So in this one, I'll be checking if the array of the value left, that is 0 for the first time, is equal to x, value x. If it is so, I say return minus 1. Oh, sorry, return a of left value. I want to return the left value. Yes, it is there. And now I can, make your life easy. I can put the brackets here, so you should not be confused. So this is my loop is complete now. Now, if the loop ends and the value we didn't find the value, so what we need to do? Return minus 1. That's it. So let's try to compile this program. I say csc ls1.cs, and I got some problem. So okay, so linear search. So we are having 1, 2, 3. I need some array. Okay, it should be like this: integer array A. Compile again. Now the problem is solved, ls1, and I have to pass a value. For example, I pass the value 3, it says not found, but if I say 3, it found. Okay, so similarly, if I say 55, not found, but if I say 35, it found. So that is how we are searching for our value using the linear search. Okay, now let's go and see how the recursive method works. Now in recursive method, if you see here, it's the same program, same search method, but the implementation of the search method is a bit different. You see, we are having the same array, we are having a left and in x and length, everything is there. Now the value of left is 0. You see here, the first time the value of length is 0. Now is 0 is bigger than length? Since we are searching from here, so that we are increasing the left every time, and if it is bigger than length, it means that we cross the limit and the value is not available, so we have to return minus 1. So if left is bigger than length, that is 10, so return minus 1. Otherwise, check, is a of 0 is equal to the value of x. So for example, I'm searching for a value 19. Okay, I'm searching for a value 19. So my x is 19 and the length is 10. Okay, the left is 0, is already there, and this my array is their complete array for the A. So what I'm going to do is I'll say, okay, if A of 0, which is 10, is 10 equal to 19, the value of x I'm searching for, answer is no. So it will not come inside, it will jump outside, it will come here, and it will say, okay, now search for value within this array, search for left plus 1. Left plus 1 means 0 plus 1 is 1. And the value of x, I know that this is 19, still the same, and the length is still the same. So it is calling again with a new value now. Now the left is 1. Is the 1 bigger than length? No. Okay, come down. Is the a of 1, now the index is 1. If the a of 1, that is 14, is equal to 19, x, no. Go outside and again do the search with the new value left plus 1. So left is 1, now the left value is 2. The x is same, the length is same, go back again with a new value. Now the left is 2. Is the 2 bigger than length? No, go outside. Is the a of 2, what is that a of 2? A of 2 is 19. Is 19, a of 2 is equal to x, that is 19? Yes, so come inside. If the condition is true, come inside and return a value a of 2, that is 19. So the index will be 19 now. So I'm checking here, if 19 is not equal to -1, okay, if it is not equal to -1, then display found. So it will go up there, condition is true, it will display found. Okay, so this is how the recursive method works. And remember one thing, every time it calls a method, it is creating a function, is occupying a space. So this is the call when left was 0. Then it calls another method, so it is another space when the left is 1. And it calls another method again when the left was 2. You see that? Every time it makes a call is occupying a space. So when it returns, khalas, it is returned, is finished, the value is gone, and it comes back here to the index, and it comes here and it displays whether it is found or not found. So let's try this method on the computer. So what I will do is I'll just try to delete this part, okay, and now I'll try to implement the recursive method. So I'm going to say if the value of left is less than is bigger than length, okay, if it is so, then please return -1. You know, I can write in one line as well if it is one condition. I can check for another one. If a of left, okay, is equal to x, then return return a of left. Okay, if it is not, then you have to call. You say, okay, return, and then call linear method, linear, LINEAR search with the value a, okay, and then left plus 1, and then the value of x is same and the length is same, and that's it. Now the beauty of recursive is the code is always very short, okay, and it is easy to manage. So let's save it and compile it. This is done, and now I can run ls1 and I can say, okay, I'm searching for 26, for example, and I got found. Okay, how about 25? Not found. You see that? So research is the search is also working in a recursive way as well. So let's search for the 44, by the way. Oh, found. And how about 45? Not found. So this is how we can do the search in a recursive way. So let's see what we have now. That's it for today. Kafara majlis. Subhanallah wa bihamdihi. Subhanakallahumma wa bihamdika. Nashhadu an la ilaha illa anta. Nastaghfiruka wa natubu ilayk. Assalamu alaikum wa rahmatullahi wa barakatuh.